Hello and welcome. This is Behind the Forgetfulness, one of the best series where we dive deep into team robots and they unveil their awesome and successful robots for Into the Deep season. Today's episode is Behind the Forgetfulness. Team 21336, I Forgot, the Washington State champions for Winning Alliance and Inspire Award. They recently broke the world record with a high of 447 no-point penalties and have the number one ranked OPR in the world. Can you start by introducing yourselves and telling us a little bit about your team?
Alright, so we're Brian, programming.
I'm Micah, team captain.
I'm Jacob, mechanical.
I'm Wyatt, mechanical.
Okay, cool. So, every team develops a game strategy to maximize the performance. What has that looked like for your team this year?
Yeah, so in past seasons, we built complex, fully carbon fiber robots, but this year, we determined to be more optimal to free build a simpler robot, which gives us more flexibility and reliability. This allowed us to build our robot with one integrated ARM subsystem, which simply and elegantly completes every task in the game, from samples and specimens to our level 3 climb.
Awesome, yeah, I can for sure see how your robot looks way different than other top robots and it still competes at a similar level. What was one of the biggest challenges you guys faced while designing and building your robot, and how did you overcome it?
We have an absolute analog encoder, which measures the actual angle of the arm rather than using the motor encoder, which is more optimal. And then in addition, we also played around with different stainless plastic and steel shim stock to reduce the backlash in our arm, and we found that the steel shim stock was a lot more optimal.
Great. So now let's move on to the programming and autonomous. Brian's FTC teams not only build but also program their robots. Do you guys have any custom programs and or code that you want to share with us?
Yeah, so a very integral part of our autos is our motion pathing library. So we currently use a custom implementation of squid to point, and that's essentially just it's similar to a PID to point, except it's more aggressive when we're close to the target. So yeah, that makes our autos a lot more accurate.
Okay, cool. And what kind of autonomouses do you guys have? With your world record, I see that you guys had a 6+0, one of the only autonomouses in the world that can do that. So can you please go through that autonomous?
Yeah, so our 6+0 is powered by vision, which also went through a lot of iterations. For example, first we used the Limelight, but we found that it wasn't very accurate at detecting the samples. So we switched to a OpenCV approach, which I'll let the other Brian talk about.
Yeah, so for OpenCV, it's just the default color blob locator process. We just run 2 of them to detect both the lines and the yellow specific samples. Yeah, it's been really reliable, and that's really what's been enabled our sub-cycle autos.
Great. So let's move on to the community questions that we got from Discord and YouTube and Instagram. So from Discord, Pride of Denather asked, what software improvements have you guys made in order to make the driver's job as easy and consistent as possible?
So we have a lot of automation in our teleop phase. For example, we just click one button for the baskets, and it'll just reach up and score samples in the high basket, as well as automatic specimen scoring, so we line up our specimen up against the wall, and then we click a button, and it'll just score the specimens by itself.
To expand upon the automatic specimen scoring, we've been having a lot of questions about that, and basically we actually as Brian was saying, we line up our robot against the specimen on the wall, and then we relocalize based off of that, and then start cycling, using the same commands as we programmed in auto.
Great. So from Arjun, he asks, how has a single step claw intake/outtake been better for you than a 2-step or roller?
Yeah, so having one way in and one way out has significantly reduced the complexity of our robot, which overall made it significantly simpler, both from a mechanical perspective as well as a programming perspective, because in previous years, having transfer mechanisms can be more difficult to handle, and this integrated system makes that a lot more manageable.
Cool. Okay, so from Tarun, he says, how did you manage your string and spoiling?
Yeah, so our string is actually really, really innovative, and I haven't seen very many teams with a similar design. Specifically, so we're rigged continuously, and probably the most innovative element of our design is on our return string. Can't really see it. We have this guitar tuner right here, and this guitar tuner allows us to alter the tension of our return string very, very easily during a match, and so this makes it extremely easy. We also, the tie-off for our extension strings are just on these slides here, and so it makes it extremely easy to alter the tension of those. And so, like, a lot of teams have moved over to belted slides because they've had a lot of issues with specifically their string tensioning, and these problems, such as string tension, were solved very, very effectively with these strategies.
And then in addition, we're using the BWT Link slides, which we've actually been using for every single season that this team has existed, which have these pulleys that are integrated directly into the slides, which makes the slides stack really efficiently.
Cool. Great. So from David, from Team 5477, how did you optimize your autonomous path, and which pathing library did you use? Which I think you guys answered.
Yeah, so previously we've talked about squint to point, so it's pretty basic. For our optimization, it's really just what is so funny?
It's pretty basic. Okay, keep going.
Yeah, okay. So for our optimization, it's really just like running it a lot. A giant thing we do is we actually live stream all of our autonomous runs, and that allows us to look back and, you know, really like get every single like tiny detail. And, you know, these kinds of things really add up, since when you're repeating like 5 or 6 actions at a time, like even like a tenth of a second, you know, times 6, you're saving like 0.6 of a second, right? So yeah, that's been really helpful.
Great. And from Ayush, I hope I said that right. He said, did you have any issues with BWT slides? If so, how did you get around them?
We haven't had too many issues with BWT Link slides. Well, I mean, these slides have remained basically unchanged since the beginning of the season. The only thing that we've had to be careful with is on our level 3 climb, the bar actually slides along the slides. So we put these plastic like inserts that essentially go over and cover these screws that would otherwise catch when climbing.
Great. And from Srav, how are your slides and pivot rigged, like the motor and spools configuration and such?
So basically we have 3 motors powering the slides, and then these are 1150 RPM motors, and then geared for more torque, 1 to 2 gear ratio on 44 millimeter spools, and then we have 2 extension strings on each set of slides, and then 1 retraction string down the middle.
Cool. And then from Dark Lights, or Dark Nights, he said, what did you use for localization?
I mean, so over here we have 2 Go Build dead wheels, and as well as a
The pinpoints.
The pinpoints, yeah.
as well as a pinpoint up here, which does all the calculations from the 2 dead wheels and allows us to basically track where we are.
I'd like to know more about how you guys made the 6th specimen during auto possible. Just like, is it CV, and then how did you, just in general, how did you manage to achieve like such a fast robot?
Yeah, so previously, before we implemented Vision, we actually got our 5 specimen auto to finish within 22 seconds in order for us to do the 5 specimen in 1 sample, the 5+1 auto, and then we implemented Vision.
Yeah, so previously, like we've talked about, it's the OpenCV color blob locator process. A really important thing though is we use D-pad input after a init, and that allows us to specify where the sample is relative to the center of the sub. And that's because, like, you know, there's just so many inconsistencies on the field, like your randomization is bad, you're going to need to specify where it is beforehand, otherwise it won't work.
Cool. And what were some special features that made your pitching slides robust?
one thing that made it really robust is like previously we just did our feed forwards and our PIDs just based off of what we called close and far. So whether our slides were like pulled all the way in, and that just caused a lot of like it would like bounce a lot when it's like really far, right? So now we changed it to scale with the slide extension, and that's been a lot more reliable.
Yeah. So in addition to that, we also modeled inverse kinematics for both the slides and for the pitching slides. So we can give an input of x and y, and then the claw will go to exactly that point. And then furthermore, we also modeled gravity feed forward for the slides in the arm, which really helped a lot.
How is your drivetrain so smooth even though it's not custom? Ratty 23405.
Yeah, so as we said earlier, like we've been using fully custom carbon fiber robots. We built fully custom carbon fiber robots in the past, but we kind of realized that especially for things that aren't really iterated upon a lot, like the drive base, it really doesn't matter if it's COTS or if it's custom. But except for the COTS one is maybe slightly heavier.
Okay, any issues with tipping or weight transfer? Average_media.
At the very beginning of the season, we actually built this robot to be really short. It stopped like right here, and we noticed that it kept tipping over. So we extended the channel backward, and we haven't really had that many problems after that.
What led to the tankish looking design?
Yeah, so we started the season with we started building a complete COTS robot, and later in the most recently I designed these side plates that because of their angled look, it overall contributes to the overall tank design.
Yeah. Cheer for you! Cheer for you! Cheer for you! Got us. Okay, ready? Okay, guys, we are selling our shirts for Worlds.
Whoa!
Yay!
Pre-orders will come. Watch out for an announcement. Pre-orders coming soon.
Okay, back behind the camera. How did you guys do a level 3 hang from Joshua the Dash XP2JB?
Basically, there are two hooks. There's the stationary hook and the moving hook. The stationary hook is attached to the central U-channel of the robot that also is the pivot of the slides. And then the moving hook is attached directly to the first of the linear slides. And basically how it works is the first arm, or the linear slides will extend and grab onto the first bar using these hooks. And then using the moving hooks, and then afterward they will transfer to the stationary hook. And once the robot is now hanging onto the first bar, once the robot is hanging on the first bar, the slides will extend again, grab the second bar, and grapple itself up to the top bar.
Wait.
I live in the farming every day. They know me where it rains. I farm apples daily.
Great.
Wow.
And, and I think that concludes our Behind the Forgetfulness episode. Thank you all for watching.